Dear students, welcome to Narayana online digital classes. It is a special session on mains question paper which one was being conducted today in the morning. All these questions are taken from the memory of students who have appeared in exam. Certainly, there would be some errors, some mistakes in question paper, even in question and alternate. Again, will be coming in front of you tomorrow with full set of question paper and correct solution. So, whatever solution I am giving you, these are for the questions which our students have memoried and has told to us. Presenting in front of you the first question from physics paper which one was conducted in the morning. Discuss the properties of image formed by shown mirror of a real object placed beyond center of curvature. Check here, you have a concave mirror. I am taking here a concave mirror, right? And this is principal axis, this is pole, here is focus, here is center of curvature. You know from the definition of focus that if object is situated at infinity, its image is formed at focus. As step by step object comes nearer to the mirror, image, real image, step by step will move away from focus. You remember, if I take beyond this line infinity, if this is position of object, position 1, its image will be formed here, I1. One step, object will come nearer, in between C and infinity, image moves one step away in between F and C. So, this is O2, this is I2. One step more nearer you come, O3, image will be formed at C. I3, object will come one step more nearer, image will move one step away. It will become I4. When object comes at focus, image will go at infinity. You have these positions when you are getting, real image of real object. When object is moving, real object is moving towards concave mirror, the convergence of reflected beam is going on decreasing. So, now when object is at infinity, you have point like image at focus, real, inverted, highly diminished. When object comes in between infinity and center of curvature, size of image will be increasing. Real, inverted, it will be slightly magnified, but still its size will not be equal to size of object, it will be diminished in size. So, if I am considering object here to form the image, what you will do? Minimum 2 rays you will take. One ray you take parallel, it will pass through focus, and second ray you take passing from focus, it will become parallel. You are getting image here in between focus and center of curvature. What type of image? It is real, inverted, diminished in size. So, when they say you that real object is situated beyond C, it means that in between center of curvature and infinity, you are getting real, inverted image and diminished in size in between focus and center of curvature. Let us see here, you have real, diminished and inverted your answer will be number 3, real, diminished and inverted. Ray diagram you can see here, I have shown you. Did you understand this clearly? Let us move to next question. Now, a cylindrical container rotates with constant angular velocity, speed, radius of cylinder shown at which water is in equilibrium with respect to container. I told you question is noted from the memory of a student. After exam, students have come, whatever verbally they have told us, based on that we have written the question. I feel that this radius they have given you r and you are rotating it with angular velocity omega. They are asking you, okay, the height h. Clear? If you will have to find that height h, take a small liquid element. I am taking dm here. Okay, this will be rotating in a circular path. Let us take for x, its radius you will be taking here. If this angle is theta, here also this angle will be theta. To see here on this dmg, its weight will act vertically downward. Okay, no? dmg, and centrifugal force here will act dmx omega squared. So you have Fx equal to dmx omega squared and Fy will be equal to dmz. Clear? If you take slope here, tan theta, that will become dy by dx. So tan theta, if you take, it is dy by dx, and from here if you are taking theta, you take theta, then this will become fx by fy. Fx by fy. So dy by dx, fx, it is dm x omega squared by dmg, dmh cancel. We have dy equal to omega squared x dx. Now you take the limit. I want this height from here till here. So the value of dy from center to this height, it is h. So I am integrating it from 0 to h, and x you take, you are taking from 0 to radius of cylinder, 0 to r. What you are getting here, differentiation and integration opposite process, this will become h and this will become omega squared. Here g is there, so omega squared g you keep here, omega squared g, this will become r squared by 2. So your answer is h will be equal to half omega squared r squared g. So omega squared r squared by 2g. Check. This will be the answer for you. Clear to you? Understood now? If you understood this, let us move now to next question. Okay? A block of mass 3m is suspended by meter scale rod. So this is 1 meter length rod As shown in figure, if tension in string A is equal to kmj, in equilibrium, they are asking you value of K. Certainly, it's a problem related to equilibrium. You will be considering rotational equilibrium. You know na, condition for rotational equilibrium. The vector sum of all the torque must be equal to 0. We will be considering torque about any point. But one thing is there, they are giving you tension in string A. If tension here we want to find out, it means that tension here is unknown. So what we will do, we will consider torque about this point. Clear? If you take torque about this point, then what will happen? You check, in this I am taking TA, here is 3 mj, and its mass is m. So here one force is acting mj, here the force which is acting is 3 mj. Clear to you? Mass 3m is suspended by meter scale of rod of mass m because its center of mass is at the middle. So mg will act at the middle. Now consider the direction. TA will like to rotate this rod in clockwise direction. mg will like to rotate the rod in anti-clockwise direction. 3mg will like to rotate the rod in anti-clockwise direction. So you take here TA into, in centimeter it is, okay, no. So you can take 100 centimeter. From here, this distance is 1 meter. Now go for mg. This is mj into 50 centimeter plus, here it is 3 mg into 25 centimeter. So you want TA. If the tension in string A is equal to kmg, okay, we want TA. 3 mg 25, so it is equal to 50 mg plus 75 mg. This is equal to 125 mg, and you will go for TA. This will become 125 by 100 mg. This is 5 by 4 mg. Clear to you? They are telling you tension in A is equal to kmg. So this is your K. K equal to 5 by 4. Answer is number 1, 5 by 4. Tell me, it is clear to you? Let us now move to next problem. Nothing I have done. Here you have taken net vector sum of all the torque, you have made 0. Better than that, I have taken anti-clockwise is equal to clockwise torque or moment of forces. Even we have not used vector concept of torque. Now, let us move to next problem. It is from photoelectricity. Stopping potential of emitted photoelectron is V. So Vs, they have given us V when monochromatic light of wavelength lambda is incident on it. You know, for photoelectricity chapter, whatever problem they will ask you, there is only one formula, Einsteinian photoelectric equation. Kinetic energy maximum equal to half mv max square equal to h nu minus w naught, where w naught is work function, equal to h nu minus s nu naught is threshold frequency, equal to SC by lambda minus SC by lambda naught. Lambda naught is your threshold wavelength. This must be equal to E into Vs, where Vs is stopping potential. So for this problem, certainly without reading problem, we can say we'll have to go for Einsteinian photoelectric equation in which stopping potential is involved. It is V when incident wavelength is lambda. If wavelength of light incident becomes 3 lambda, when it is 3 lambda, stopping potential becomes V by 4. They are asking you then the threshold wavelength of metal is. Go for SC by, I'm going for here, SC by lambda minus SC by lambda naught. This is equal to EV. For this you will go SC by 3 lambda minus SC by lambda naught equal to EV by 4. They are asking you threshold wavelength. It means that I must remove a stopping potential. For removing a stopping potential here, what we do, I'll multiply this equation from 4. You will tell, sir, why you are multiplying it by 4? If I'll multiply by 4, right hand side will become EV. So, right hand side will become equal. So, what you are getting here? First equation, keep it like this. First you do like this. So, here it will become 4HC by 3 lambda minus 4HC by lambda naught. This and this equal now. This will be equal to SC by lambda minus SC by lambda naught. This one transfer that side. If we'll be transferring that side, then it is 4SC by lambda naught plus, and it is minus 1, means 3 you are getting. You will get 3SC by lambda naught. This will be equal to, bring this one this side, 4 by 3 minus 1, 1 by 3. So, you are getting 1 by 3 HC by lambda, nothing. This one I have transferred here and this one I have transferred here. Clear? HC, SC cancelled. They are asking you lambda naught. This is equal to 9 lambda. They are telling you threshold wavelength of metal is K lambda. Find the value of K. How much you got? K. K is 9. Answer here K 9. Did you understand this? Clear now? Let us move now to next problem. Now, amplitude of carrier wave and message wave are 5 unit and 3 unit respectively. They are asking you maximum and minimum amplitude of modulated wave. Right now, the 5 and 3 they have given you carrier and this. The maximum if you take A max by A mean, this will be equal to AC, okay no, minus here maximum you want AM by AC minus AM. 5 and 3 they have given you. 5 plus 3, 5 minus 3, 8 by 2, 4 is to 1. It is equal to 4 by 1. How much simple problem it is. Okay, no? Simple. A max by A mean, AC plus AM by AC minus AM. That's all. Now, let us move to next problem. Okay, a charged particle having charge Q and speed v is moving in xy plane in x direction. It enters in a region of uniform electric field directed. So let me take here, this is x direction, this is y direction, correct? It is entering in a region of uniform electric field. In this direction, electric field is acting, and this electric field is extended from 0 to d. So 0 to d it is extended. This distance is d. What is the equation of the path in terms of d? Clear? Particle, check. It has charge q, and it was moving with velocity v along x direction. So when it has come here, its velocity was v. You know, yeah? Along x direction, it will move with constant velocity, and along y direction, it will move with constant acceleration. Ax 0, Ay Fy by m, this is Eq by m. Clear to you? Understood? No? This is the force, this is the mass. Now suppose this distance d it covers in time t. So d is x. You take like x equal to vt. X is how much? D equal to vt. This is equation 1. Now you go for y direction. Your y will be equal to uyt plus half ayt squared. Simple kinematic equation. Your uy is 0 because charged particle has entered along positive x direction. So this will be equal to half ay t squared, half ay is eq by m. T squared from here you take. T is d by v. So t squared will be d squared by v squared. So what is your equation? Finally, I am writing here y equal to half eq, okay, no, d squared by mv squared. Check here, where is the answer? Your answer will be y equal to half eqd, qe d squared by 2mb squared. Answer will be 1. Did you understand this? Clear now? Simple. In the same way, in projectile motion also you have done, no? Concept remains same. Okay, no? Let us move now to next problem. A proton enters in a uniform magnetic field of 2 millitesla. So let us write first B. They have given you 2 millitesla. At an angle of 60 degree with the magnetic field, V 10 meter per second, theta 60 degree, find the pitch of the path. Okay, no? So what will happen? I am taking, they have told you at 60 degree. So I am taking magnetic field like this. Clear? And charged particle is entering here at an angle theta with velocity v. So this v will have two components, v cos theta, and here it will be v sin theta. So at right angle to magnetic field component is what? V sin theta. Due to this, you know in magnetic field, your charged particle will move in circular path. But due to V cos theta component, it will be displaced. So path tract will be helical. So what will happen? It will start moving in helical path. The distance between any two turn in helix is called pitch. How much this distance will be? So my pitch will be equal to V cos theta into time period. Now we want time period. For having time period, you will have to go for radius of circular path. How much radius? You know, centripetal force is being provided by force BQV. So you have proton BeV will be equal to mv squared by r. V perpendicular. So what will happen? One V perpendicular is cancelled. Clear to you? So what will be R? R will be mv perpendicular by BE. You want time period. Now time period 2 pi R by V perpendicular. So this is equal to 2 pi R you have here mv perpendicular BE V perpendicular. This V perpendicular means V sin theta. These two cancelled. So time period is 2 pi m by BE. Clear to you? Understanding this now? It is, you check here, it does not depend upon your velocity. Nowhere V is there. V perpendicular is cancelled. So you want pitch of the path. Your pitch now is V cos theta. V is 10 cos 60, 1 by 2 pi MBE. So you will have 2, pi is 22 by 7 and it is proton, okay no? You will be taking mass of proton directly you can use or 1836 into 9.1 10 to the power minus 31 you take and this divided by charge on proton. Charge on proton, you know, that will be equal to charge on electron 1.6 10 to the power minus 19. You will be taking 1.6 10 to the power minus 19. Calculate it, okay, you will be getting 50 pi micrometer. From here, this pi, no need to change, let it be pi because in the answer pi is there. Clear to you? Main part here is, if any charged particle enters at certain angle in a uniform magnetic field, the track will be helical. And for helical path, whatever will be the separation between any two turn, that will be the pitch, which is equal to V cos theta into time taken by charged particle to complete one rotation. So main thing is here, and T, you can remember it as a formula 2 pi m by BQ, because here proton we have taken, so I have taken E. Clear to you now? Now let us move to next problem. Now this is Young's double slit experiment. Every year you will be getting one question, either to be mains or advanced, one question on Young's double slit experiment. Let me roughly draw the figure. You have one slit, in front of it you are arranging two slits, and here there is a screen. This is perpendicular bisector line. This is A, B, this is source. Here this distance is D, this distance is capital D. Clear to you? Now, they have given you slit YDSA, slit width is 1 millimeter and distance of a screen. It is not slit width. This is the separation between two slits. Slit width you are getting in diffraction from Hoover class of diffraction. In YDSA, they will be giving you the separation between two slits. As I told you, we have taken these questions, whatever students have memorized and told to us. Okay, now? So, I think this is a small d. Small d is 1 millimeter. Distance of a screen from the two slits, capital D, 1 meter. Wavelength of light, lambda, 632 10 to the power minus 9 nanometer, formed at y equal to 1.270 millimeter. Then find the path difference. We can get path difference from here only. Okay, no? They are giving you in a standard YDSA, slit width is 1 millimeter, distance of a screen they have given, wavelength of light is 632 nanometer, and bright fringe formed at y equal to the beta, if I will take it is lambda, okay, d by d. If you want path difference, my path difference is path difference, this is x d by d. Okay, if I will take here, how much path difference you are going to get? I am going to get first for x, this is the bright fringe. Okay, no, this angle is theta, this is beta, this is capital D. So, I will take this distance as x right now. So, my x is beta from here lambda d by d, and then you will have check from here 1.270 they have given me. So, directly when they are giving 1.270, no need of beta, I will be taking 1.27, clear to you, millimeter 10 to the power minus 3, small d 10 to the power minus 3, capital D 1 meter 1. So, I am going to get 1.27 micrometer. Okay, I don't need this lambda here, this will be required for beta. They are not asking us fringe width, simply x d by d, in which they have already given me x. So, my answer is 1.27 micrometer. Clear to you? Understood now? If they will be asking us fringe width, then I may need lambda. So, lambda value they have given you only for bluff, right? To confuse you. Now, let us move to next problem. Yeah. Angular velocity of a smooth parabolic wire y equal to, they have given me y equal to 4cx square. About axis of parabola in vertical plane, if bead of mass m does not slip. Okay, no. So, here it is not slipping. In this direction, centrifugal force will be acting, right? So it will have this component, and here is mg. Okay, it will have this component, this should be equal. If I will take the angle theta, so this angle is theta, this is tangential, so this will become 90 minus theta mg sine theta, and here it is m omega s squared. This distance you take as x, okay, no, cos theta. These two components must be equal. So from here first you take slope, tan theta dy by dx. If you take here, so how much you are getting? 8cx. Actually, you are differentiating it with respect to x, 4c is constant, x squared differentiation with respect to x is 2x, 8cx, that's tan theta. Here you go, you have m omega s squared x cos theta, this is equal to mg sine theta. M is cancelled, omega s squared, you have cos theta here, g tan theta x. Clear? You have tan theta as 8cx. So omega s squared g by x, tan theta is 8cx, x is cancelled. We want omega. So omega will be under root 8gc, it is 2 root 2, okay, gc. So answer will be 2 under root 2gc, answer number 4. Please check it. We have just equated the component of centrifugal force, okay, from mg sine theta, means in tangential direction, because it is not sliding, it is in equilibrium here. Clear to you? I hope you understood this. Let us move now to next problem. Now you have a capacitor of capacity 5 microfarad. You have C1 5 microfarad and it is charged to V1 220 volt, and now it is connected by uncharged capacitor C2 2.5 microfarad. Find the heat loss in the process. Simple. Calculate initial energy, calculate final energy. Whatever will be the difference, that will be lost in the form of heat, light, sound, all. So if they are asking you heat loss, we cannot say this will be complete loss. It will be in the form of light, in the form of sound, in the form of heat. Anyhow, let us take, suppose this is one capacitor and this is other capacitor. When you are connecting this positive, this will be positive, this will be negative, this is negative, it will be parallel combination. So we will go for first V common. This will be equal to, if you are going for Q net by C net, the Q net C1 V1 plus C2 V2 by C1 plus C2. Here V common, you check here C1 V1, here V2 is 0 by C1 plus C2. Clear to you? Understood now? So what is energy initial? Half C1 V1 S square, half C2 V2 S square. Clear? V2 is 0, So this energy is 0. We have to calculate this half. C1 is 5, 10 to the power minus 6. V1 squared is 220 squared joule. This is initial. Now you will go for final. So final energy, this is half C1 plus C2, C1 plus C2, V common squared. So this is equal to half C1 plus C2, 7.5, 10 to the power minus 6. And now V common we can calculate from here. This is equal to 5, you will be taking directly into 220 by 7.5, micro is there, it will be cancelled. So this will become 2.5, 2 times and 3 times. So you will have 2 by 3 into 220 squared. Clear to you? Understood this? Now just subtract that, your answer will come. So here it is, if you are going for this, it is 2.5, 10 to the power minus 6. So it is 10 to the power minus 6, 220 squared. Here if you go, so it is 4. 4 means 1, 2 will be left. This will become 15. 15, 4 is there, 1, 2 is going to 7.5 into 2, 15 by 3, 10 to the power minus 6, 220 squared. Check from here. From here 2 is going, 1, 2 is left, so it is 15, 3 into 3. Okay, no? So 3 into 3. So it is 5 by 3, 10 to the power minus 6, 220 squared. So here it is 5 by 2, okay, and here it is 5 by 3 and 220 squared. So loss of energy will be, this part is common. So 2, you will be taking that 220 squared into 10 to the power minus 6 you keep here. Clear? And this is 5 by 2 and this is 5 by 3 into 5 by 2 minus 5 by 3. It is 15 minus 10. You will be checking here 15 minus 10, 10, you have 5 by 6. So you will have 220 squared 10 to the power minus 6 into 15 minus 10, 5 by 6. When we will be calculating 10 to the power minus 3 is there, so 2 gone, you will be getting 2484. 484, 10 to the power 2, 10 to the power minus 4, 5 by 6. Okay, if you will divide by 2, it will be, let me write here, loss of energy now. This will be equal to, because answer 3 here, 2 you will be getting 242. 242 into 5, 10 to the power minus 4 by 3. It is 0, 1, 2, 12, 10 by 3. Okay, no? Into 1, 0 I have already removed. 10 to the power minus 3 joule. Is it clear to you? Understood now? So answer will be number 4. 1210 by 3 into 10 to the power minus 3 joule. Simple. Initial energy minus final energy, that will be loss of energy. Okay, now only one thing in the question I am not satisfied with heat loss, because it will be lost in the form of heat, light, sound, all forms of energy it will be. Now, let us move to next problem. Fundamental frequency of two identical strings X and Y are 450 Hz, 450 Hz, and this is F1 and F2 300 Hz. Find the ratio of tension in string X and Y will be. They are identical string, you remember. Fundamental frequency F, you know, 1 by 2L under rho T by mu. Clear? Now, they are telling you they are identical strings. If they are identical strings, it means mu is same, L is same, F will be proportional to rho T. Clear? Ratio of tension they are asking me. It means that my T is proportional to F squared. String X, they have told you 450. So this is my X and this is my Y. So I will have Tx by Ty will be equal to, check here, they are asking find the ratio of tension in string X and Y. Okay, so this will become F squared. Okay, no? So you will have Tx Fx by Fy squared 450 by 300 squared, 0 cancel, 3 times 15, 2 times, I am getting now Tx by Ty 9 by 4. Clear? Check here. Answer is number 2, 9 by 4. I hope you have clearly understood this fundamental, law related to vibration of any stretched string. Okay? Now, let us move to next problem. In a hypothetical spherical galaxy, mass density is given by, mass density means they have given me rho as K by R. Planet is spherical galaxy. In that, planet is rotating at R0 distance from center of galaxy. I think some star would be there, because in galaxy, right, planet will be there, but planet will be rotating around a star. Okay, the children, while telling verbally, perhaps they have done this silly mistake. There may be a star which is rotating around the center of galaxy at a distance R0. They are asking you time period and radius. Clear? So first till R0, it is galaxy. We'll have to consider how much mass I should consider. For finding the mass, I'll go for, distance, so my dm will be equal to rho dv. Clear? Now, this will be equal to rho dv, 4 pi r squared dr. Some arbitrary distance I have taken, whereas the limit of small r I will take from 0 to r0, from center to r0. This will be equal to k by r, 4 pi r squared dr. This is dm. Clear to you? So, this one I will take 0 to m till where star is. Till there, I am considering the total mass of galaxy. Okay, till the edge, from the center of galaxy till there, what is the mass of galaxy I am taking. This R, 1 R is cancelled. You are integrating it. I will integrate it from 0 to R naught. R naught. So this will become M. 4 pi K. Integration of 0 to R naught, R dr will become R naught squared by 2. R naught squared by 2. Here it is 2. M will become 2 pi K R naught squared. So you have 2 pi K R naught squared. Now they are asking you time period. So whatever is the gravitational force acting between that star and the galaxy, that will be providing necessary centripetal force. So I will have G, M, suppose mass of a star is M, R naught squared, you will have to take centripetal force. So M, R naught, omega squared. They are asking you time period. So 4 pi squared by T squared. Now capital M value you can substitute. You will have G 2 pi K R naught squared by R naught squared, M R naught 4 pi squared T squared. Now R naught squared I have removed. 1 pi I am removing. Okay, and this is you have taken G M 2 pi K R naught squared you have taken by R naught squared. Here is one more M. This M is cancelled. Clear? Now this 2, this will become 2. What is left this side? This side left quantity is ZK. Okay, and this side left quantity is 2 pi R naught by T squared. So my T squared equal to 2 pi R naught by GK. What's the value of T now? T will be equal to under root 2 pi R naught by ZK, where it is 2 pi R naught by KZ. Answer is here. Number 3, under root 2 pi R naught by KZ. Did you understand now? A beautiful problem, undoubtedly, whereas concept part is concerned, in mains, undoubtedly a nice problem. Let us now move to next problem. Yeah, a coil of radius r rotating about a diametrical axis figure they had given you with angular velocity omega. So here you mark omega in a uniform magnetic field V. Find the maximum voltage developed. Phi is how much? A dot B, AB cos theta, theta is omega t. Clear? Now, they are asking you maximum voltage, EMF, E equal to minus d phi by dt, magnitude part they are asking me. So I will go only for d phi by dt. So AB d by dt, minus is already there, cos omega t. So this will become AB omega sin omega t, minus minus plus. Clear to you? So E max, E equal to E max, you know maximum value is 1, sin omega t. So my E max This is equal to AB omega. Clear? Now, we'll have to calculate A is pi r squared. It is pi r squared B omega. Okay, they had given me with angular velocity omega. For half rotation it takes a time 0.2. So you can take it as 2 pi by t. Clear? So for half rotation 0.2 second, for full rotation it will be 0.4 second. So your E max, okay, this will become pi, because there you have pi squared. So I will take pi squared as 10. This pi squared I have taken 10. R squared, okay, 10 is 0.1. R squared 10 to the power minus 2 we will take. Okay, so pi squared already you have taken. R squared you have taken. B is 5 10 to the power minus 5 into 2, and T is 0.4. So it is 4 into 10 to the power minus 1. Clear to you? So this will go 2 times, 2 5 times. It is 25. Okay, no, 5 into 5, 25, 10 to the power minus 6 volt. So your answer is 25 into 10 to the power minus 6. You can make it as 2.5 10 to the power minus 5 volt. Answer is here, 2.5 10 to the power minus 5 volt. Tell me, did you understand? Clear, no? Now, let us move to next problem. Okay, dimensional analysis, the application, a very nice problem. They have given you force, velocity and area, each considered as fundamental physical quantity. Find dimensional formula for Young's modulus of elasticity. You must know all these quantities. Young's modulus, they are telling you, take a constant. It is depending upon force power A, velocity power B, area power C. Get the value of A, B and C. Okay, no? Young's modulus is nothing but, okay, force by area, stress you will be taking, no? So why not you will be considering Young's modulus, stress by area, it will be easier. The best way is there to take in terms of MLT and then to get the value of A. Okay, no? So I will be considering for Young's modulus, trying to develop F by A. This is equal to, okay, K F A. Okay, no? But there will be a problem here, because their area, velocity, if you will be taking, there will be, you check, nothing will come here, because A already you have. So VB, this is the shortest technique I am telling you. Correct method also I will tell you. A power C. So this is A power C. Compare, na? It is a dimensionless constant. Here, principle of homogeneity you are using, undoubtedly modified technique. F1, A1, check here. Here A power C, here A power minus 1, C is minus 1. V does not exist. So B will be 0. So Y will become how much? Dimensionless constant K F1 V0 A power minus 1. Clear to you? So answer will be F1 V0A minus 1. Anyhow, objective based exam, no. To save time, you can use this technique. You are going to get correct answer. Answer will be A here. This will be the answer. But the correct method is dimensional formula for all you take. For example, your Y is MLT minus 2 by L2. Clear to you? This will become M L minus 1 T minus 2. Same way, F, you will have to write M L T minus 2. V, this will become LT minus 1. A, this will become L2. And then you will have to substitute here, and then you will have to get the values of A, B, and C, and then you can substitute in that expression, you will be getting the correct answer. For this specific problem, because Young's modulus directly I have taken F by A, the very shortcut technique we have used. Clear to you? Understood now? Here they are not asking how you are solving it. They want the key at any cost in the shortest duration of time. So this is the best technique in my opinion. Now, please move to next problem. Correct order of resistivity will be aluminium, mercury, copper, tungsten. Now, one thing is there. Either you mug up or you should minimum remember which is the best conductor. In these four, if you take copper as the best conductor, it means it will have minimum resistivity. Then aluminium, okay, then tungsten, and undoubtedly you know mercury after that. So here you see resistivity. Resistivity will be maximum for mercury. It will be greater than tungsten, resistivity of tungsten, and then it will be greater than resistivity of aluminium, then it will be greater than resistivity of copper. Certainly a tricky question. For that, NCERT book you will have to go through. Okay, no? Because this type of questions only you can answer when you will be knowing minimum roughly, okay, either resistivity values or which is better conductor. Clear to you? So answer here, you can check. This answer will be rho copper will be lesser than rho aluminium, lesser than rho tungsten, lesser than rho mercury. Answer 1. Now let us move to next problem. Two train A and B moving with the speed. First, VA. This is equal to 36, means 10 meter per second. Okay, no? And B, VB moving with 72, means 20 meter per second. Okay, in opposite directions. So I am taking this one is train A moving in this direction. So I am taking IA, and B is moving in this direction. So minus I. Clear to you? A man moving in train A with the speed 1.8 kilometer per hour opposite to direction of train. Means in train A there is a man which is moving in opposite direction. 1.8 kilometer per hour opposite to direction of train, they will have to think that it is with respect to train or with respect to ground. Certainly it will be with respect to train, because they are giving you 1.8 kilometer per hour, the velocity of man with respect to A. Clear? This one they have given you 1.8 into 5 by 18 meter per second. A is moving in this direction, so it will move in opposite direction. This is minus I, 5 by, check here, 10. It will become 18, 10. This will become 0.5 minus I. Clear to you? Find velocity of man as seen from train B. So they are asking you velocity of man, vector. All these in vector form you take. With respect to B, they are asking you. I need absolute velocity of man first. So this one is velocity of man with respect to train A, Vm minus Va. So velocity of man Vma plus Va. Vma is minus 0.5 I minus 0.5 I, and Va is plus 10 I. You are getting 9.5 I. Clear to you? Now they are asking you velocity of man with respect to B. So this will be equal to velocity of man minus velocity of B. Check it. Now this is with respect to ground. This is the absolute velocity of man. So Vmb, velocity of man with respect to B is Vm 9.5 I minus Vb. Vb is minus 20 I. So how much you are getting? Minus 29.5 I. It means that if there is an observer sitting in train B, if he will observe the man, he will feel that he is going with velocity 29.5 meter per second along the direction of train B. Direction is minus I. So answer you check, they are only asking magnitude. So magnitude is 29.5 meter per second. I hope you have clearly understood this. Relative velocity, a simple but beautiful problem on relative velocity. I hope you have clearly understood. Let us now move to next problem. 3 mole of oxygen mixed with 5 mole of argon at temperature T. Internal energy they are asking you. Internal energy is N1Cv1T plus N2Cv2T. In a very simple way we are remembering. Okay, for monoatomic gamma, okay, when you are taking 5 by 3, Cp 5R by 2, Cv 3R by 2, diatomic 7 by 5. This is monoatomic. Diatomic 7 by 5. 7R by 2, Cv 5R by 2. Let us check here. N1, 3 mole of oxygen, 3. Cv 5R by 2T. Okay, N2 5 mole. Cv2 is argon, 3R by 2 into T, 15 by 2 15 by 2, 15 RT. Simple. Total internal energy 15 RT. Answer will be number 3. I hope you understood it clearly. Internal energy, change of internal energy is NCVDT. Internal energy, NCVT. Clear now? So, if you go, now, next problem is in front of you. A body of mass m moving with velocity ui. Ui, they have not shown, collides elastically with a stationary body of mass 3m as shown. Velocity of m after collision is Vj. Okay, no? So, first I will be considering conservation of linear momentum along x and y direction. Okay, no? They are telling you this body is at rest. Velocity of m after collision they have given me. So, initial linear momentum I have MUI, clear? This one is at rest, I am taking along x direction. So, this will be equal to, this one is moving after collision along y direction. So, it does not have any component along x direction. So, it will have only 3m, okay, no, and I am taking Vx. So, my Vx will be u by 3I. Clear to you? Understood now? Now, I will go for Vy. Now, it does not have any component along y direction and second body is at rest. So, this is 0 and now it is m, y component they have given you Vj. So, I will be taking this, you take as V dash better. Vx is mv, y direction, plus 3m vy dash. Dash symbol I am using for velocity of mass 3m. Because they are asking you the velocity, the value of v's, they are asking you this v. Clear to you? I have velocity of m after collision. This is the final velocity of m. So, now from this mm cancel, vy dash, how much you are getting? Minus v by 3. Clear? So, this is z. Understood? If you want velocity of 3m, okay, the velocity of 3m, how much you are getting? Velocity of 3m, that is your v dash you have told, u by 3I minus v by 3z. Clear to you? Now, use conservation of energy, kinetic energy. How much you are getting? Places only here. I have initial half m u square. Kinetic energy is a scalar quantity. This will be equal to half m v square plus, one thing you check, if I am taking velocity, then this v dash of 3m will be equal to under root, because these two will be mutually at right angle, no? So, it will become u by 3s squared plus b minus s squared is plus na, b by 3s squared. So, this is initial kinetic energy. Now, final kinetic energy you are going half mv squared plus half 3m this s squared means u by 3s squared plus v by 3s squared. Check it now. All quantities are in terms of only u and v. So, first I remove half, m. Clear? What I am getting here? U squared Here I am getting Vs squared plus, okay, no. Here it is 3 and here is 3. So 1, 3 you remove. You are getting Us squared by 3 plus Vs squared by 3. Clear to you? This one will come this side. This will become 2Us squared by 3. 1 minus 1 by 3 is 2 by 3. And here 1 plus 1 by 3. It will become 4 by 3 Vs squared. 3, 3 cancel. It will be 2 Vs squared Us squared by 2. I want V. Correct now? So V will become U by root 2. Answer number 1. Check now. I had used conservation of linear momentum, conservation of kinetic energy because collision is perfectly elastic. You cannot use conservation of kinetic energy unless collision is not perfectly elastic. Clear to you? Now, let us move to next problem. A block of mass m starts slipping from top of inclined plane at B and comes to rest at the bottom. Okay? If BC is 2AC, figure is just in the middle they had given BC is 2AC. So if I will take it L, so this will be your 2L, total length will be 3L. Okay, no? They have shown here also 3L sine theta. Okay. If BC is 2AC, I have taken this as L and this I have taken as 2L. Oh, sine theta will be x by 3L, x, yes, this will be 3L sine theta, good. Friction coefficient of part AC, this part is smooth, this part is rough, then find the value of K. Better use concept of work energy theorem. Here work is being done by gravitational force and frictional force, and body has started from rest and finally it is at rest. So if I use work done by gravitational force plus work done by frictional force, this will be change of kinetic energy and already it is 0. Clear to you? Now, work done by gravitational force. It is falling for height 3L sine theta and it is coming down. The work done is positive. The work done by gravitational force, already you know, mgh. So it is mg 3L sine theta minus, because frictional force is opposing and it is coming down. Right now, frictional force is how much? If I am taking body here, so here is mg, here is mg sine theta, here it will be mg cos theta, this will be n will become mg cos theta. So frictional force is mu n to n, mu mg cos theta. Clear to you? So this will become equal to, only for length L it moves. So force is mg mu mg cos theta into L, this is 0. So my mg 3L sine theta, this is mu mg cos theta into L. mg I have cancelled, 1L is cancelled. I have 3 sine theta by cos theta, tan theta, mu. They have told you mu equal to k tan theta. Find the value of k. So the value of k equal to 3. Answer 3. Check it. Did you understand this clearly? I have simply used work done by all the forces, okay, acting on the body, and I have equated to a change of kinetic energy. Now, let us move now to next problem. Find minimum value of F applied perpendicular to line OP. Means this angle is 90 degree. This is R, this is R. Where O is center of the ball, mass M, radius R required to lift the ball. They are asking you minimum value of F. Check here. This F will rotate it in clockwise direction. In this direction, mg is acting, its weight. Clear? And this will try to rotate it in anti-clockwise direction. It means that my F into R, because angle is 90 degree, okay, no? This must be greater than force into perpendicular distance, mg into, this is the line of application of mg. You have taken torque about this point. So this distance will have to take. This distance is A. So this distance will be A minus, this distance is A. You will have this R minus A. Clear? I want this distance. mg into some name you give better, OP. If I am giving this name A, the AP, mg into AP. They are asking you the value of F. So F should be greater than equal to mg into AP by R. So if you go for F greater than equal to mg, now I want AP. This AP is this AP base under root hypotenuse square minus perpendicular R minus A square. Clear? So this AP will be R squared minus R squared. Check here, minus is there. Minus A squared plus 2RA. R square cancelled. It is 2. So this is under root 2AR minus A squared. This is AP. Now substitute here. F should be greater than equal to mg into AP under root 2AR minus A squared by R. Check the answer here. mg under root 2AR minus A squared by R. Answer will be number 2. Tell me, did you understand? Clear? You have taken torque of two forces for F. Clockwise for mg. Anti-clockwise, if you want that this ball should climb up. Okay, no. It should be lifted up this step. Then this torque should be minimum equal to torque due to mg, or it should be greater than torque due to mg. Clear to you? Answer is number 2. Now, let us move. Okay, only these many questions were there. I feel that you people have clearly understood. Paper, undoubtedly moderate paper it was, and a beautiful paper in physics. But one thing, all these questions, our children, our students, they have gone for writing exam, and verbally they have told. Based on that, we have noted and we have presented in front of you. There will be chances of, because verbally they have told, so there will be chances of some errors in questions or in alternates given, in options given. Again tomorrow, I will be coming in front of you with complete all questions, and correct questions we will be taking, and then I'll be presenting again in front of you. Clear? Okay? So, whatever questions we got from these students, those questions only, and that one also verbally, I have explained in front of you. Thank you to all of you.